One strategy to understand a regression model with indicator variables in it is to find the model for the mean for each category that those indicator variables represent. In this example, using the meadow foam case study, our regression model has an intercept term, beta 0. It also has a term for the continuous variable for the light intensity that the seedlings received, and a term for the indicator variable, early, which indicates if the seedlings received the early light treatment. So let's find the model for the mean for the categories of interest here. We have two categories, the early light treatment and the late light treatment. For units with the late light exposure, that early indicator variable takes the value 0 because those seedlings didn't get the early treatment. So our model for the mean number of flowers given or as a function of the light intensity when the early indicator variable takes the value 0 is simply beta 0 plus beta 1 times the light intensity. We aren't specifying what that light intensity is, so we'll just leave it in our model. It's beta 1 plus beta 2 times the early indicator variable. In this case, because the unit's got the late light treatment, that variable takes the value 0. And then we simplify this. So beta 2 times 0 is going to be 0, and that term will disappear. So we end up with beta 0 plus beta 1 times the light intensity. So for units that get this late light exposure, the model for the mean number of flowers is a straight line function of that light intensity. And that straight line has intercept beta 0 and it has slope beta 1. Okay, now for the units that get the early light treatment. In that case, that early indicator variable will take the value 1. So we're interested in finding the mean number of flowers as a function of the light intensity when the early indicator variable takes the value 1. Again, we can just start writing out our regression model and substitute in anything we know. We have beta 0 plus beta 1 times the light intensity plus beta 2 times the early indicator variable, and in this case that early indicator variable has the value 1. And now we simplify. Beta 2 times 1 is just going to give us beta 2. So we'll have beta 0 plus beta 1 times light plus beta 2. We might rearrange this further and group together the terms that don't involve the light variable, in which case we'd have beta 0 plus beta 2 plus beta 1 times light. And once again, we see that this model for the mean number of flowers for the units that get the early exposure is again a straight line function of the light variable. This time the intercept is beta 0 plus beta 2, and the slope is beta 1. So if we compare these two models for the two different categories, we see they both share this beta 1, the same slope for the light variable. So these two categories are both have models for the mean, which are straight line functions of light with the same slope, the difference being that the two straight lines have different intercepts.